So we're tasked with this problem. We have to determine if the integral converges, and if so, we have to calculate the integral whenever possible. So we have the integral from 0 to 1 of x over square root of 1 minus x dx. So we want to know if the integral here converges, and what that means is we want to know if this integral over the interval from 0 to 1 gives us a finite value. Now the most straightforward way to find if the integral converges is to actually integrate the function, find the antiderivative, and evaluate the function from 0 to 1. And if we get a finite numerical answer, then we know it converges, and if we don't, then we know it diverges. So first things first is we have to acknowledge that this is an improper integral. And how do we know that? Well, let's look at this upper bound right here, x equals 1. So let's look at our function at x equals 1. So at x equals 1, then x over square root of 1 minus x, well, that's going to equal 1 over square root of 1 minus 1 equals 1 over 0, which we see goes to infinity or is undefined. So if we were to actually plot this function on an xy coordinate plane, let's just say that this is x equals 1 right here, then we would see that the function looks something like this, where the function just extends to infinity forever as x approaches 1. So what does that mean? Well, that means that the function that we're integrating is actually undefined at x equals 1. And what's the significance of that? Well, that means that this is an undefined upper bound for our integral, because the function that we're integrating is actually undefined at this point. So to fix that, we have to actually rewrite this integral. So what do we have to do? We have to take the limit as b approaches 1 minus. And what does this 1 minus mean? Well, that means approaching 1 from the left side, from negative infinity. And why do we have to approach it from negative infinity? Well, if we look at the right side of 1, well, this function is actually not defined after x equals 1. So it wouldn't make sense to approach the function from the right side because this function is actually not defined on the right side. So we have to approach the function from the left side, or from negative infinity, from the left side of 1. So that's what this 1 minus means. So the limit as b approaches 1 minus the integral from 0 to b of x over square root of 1 minus x dx. And then so all we're going to do here is then we're just going to find the antiderivative of this function, evaluate it from 0 to b now, and then take the limit as b approaches 1. So this is essentially the correct way to evaluate an integral with undefined bounds like this one, because this way is technically incorrect. This way is technically incorrect because of this undefined bound right here. And it's more of a notation thing than anything, because it doesn't really change the way we take the antiderivative of the function. The only thing that changes now is that we have to evaluate the integral from 0 to b and then take the limit as b approaches 1. So that's really all we're doing here. It's just a more correct way of integrating this function. So let's go ahead and start integrating. So if we look at our function x over square root of 1 minus x, we see that this is actually just x times 1 minus x to the negative 1/2. So what is this? Well, this is just the product. And what do we do when we integrate a product? Well, we have to integrate by parts. So the anti-product rule, going back to Calc 1, a little refresher from Calc 1, the formula for integrating by parts is the integral of f times g derivative, there's our product, is equal to fg minus the integral of f derivative times g. So looking back at our product right here, at our function, so we're going to choose f to be x, we're going to choose x to be our f, and then 1 minus x to the negative 1/2, that's going to be our g derivative. So this is going to be our derivative in this case. So what we can do now is we can just give the anti-product rule a sort of skeletal structure right here. F derivative times g. And then we can just fill this in using our function right here. So let's just go ahead and do that right now. So f is, well, x is f, so we'll just do that right there. And then g is going to be the integral of this, because remember, this is our derivative. So we have to take the integral of 1 minus x to the negative 1/2. And so let's just go ahead and do that right now. Well, how do we do that? we'll just add 1 to this exponent right here, so negative 1/2 plus 1, that's going to be positive 1/2, so that's going to be 1 minus x to the positive 1/2, and then we'll divide by this new exponent, so divided by 1/2. But we're not done yet because we have this negative as a coefficient in front of the x, so what we have to do to take into account for that is we have to multiply this whole thing by negative 1. And then what do we get? Well, this divided by 1/2, that just turns into a 2 in front of the 1 minus x. So we're going to get times negative 1, so we're going to get negative 2 times 1 minus x to the 1/2, or negative 2 times square root of 1 minus x. So let's just fill that in here, times negative 2 square root of 1 minus x. And then minus the integral of f derivative. Well, f derivative is just 1, so that actually works out quite nicely. This function actually just goes away in this next integral right here, so all we have to do is integrate this function right here. So g, we'll plug that in, we just figured that out, is negative 2 square root of 1 minus x. So now all we have left to do is to just calculate this integral right here. So let's go ahead and do that right now. So we have negative 2 times 1 minus x to the 1/2. That's what we have to integrate right there. So let's just go ahead and do the same thing. So add 1 to the exponent. So we have negative 2 times 1 minus x to the 1/2 plus 1. That's 3/2. And then divide this whole thing by the exponent right here. So divided by 3/2. And then, of course, we have to take into account for this negative. So again, we'll multiply by negative 1. So we see that the negatives cancel out here. Dividing by 3/2 is just the same thing as saying multiplying by 2/3. So let's go ahead and bring out the 2/3 right here. And then multiplying this whole thing, or seeing the coefficients right here, we get 2 times 2 is 4 over 3. So we get 4/3 times 1 minus x to the 3/2. So what do we get as our end result? Well, we end up getting negative 2x square root of 1 minus x minus this integral. We got 4/3 times 1 minus x to the 3/2. And now we're going to evaluate this from 0 to b. And then from there, we're just going to take the limit as b approaches 1 from the left side. And so that's essentially how we evaluate our improper integral. So let's go ahead and do that. Pretty straightforward. So negative 2b square root of 1 minus b minus 4/3 times 1 minus b to the 3/2. And then minus all of this, so negative 2 times 0 square root of 1 minus 0 minus 4/3 times 1 minus 0 to the 3/2. And we'll see that right here, this negative, these negatives all cancel out, so we can just make all of these positive right here. And then as if we take the limit as b goes to 1, then all of these b's become 1. So as b goes to 1, then all this expression right here becomes 1. So 1, 1, and 1. And what do we see? Well, this goes to 0. This also goes to 0. And what is this? 2 times 0 times square root of 1 minus 0. Well, this 0 right here, that means this also is 0. And the only thing left for us to evaluate here is our 4/3 times 1 minus 0 to the 3/2, which just ends up being 4/3. So there you go. That is the finite numerical value for this integral, and we see that because we have a finite numerical value, that this function converges.